This is the first section in Chapter 10, Trigonometric Identities and Equations. And although it's a very complex looking diagram, I'll try and make it straightforward for you. This is all about angles basically, and finding the sine, cos and tan of an angle. So for example, sometimes you find the sine of an angle and the answer is positive. Sometimes you find the sine of an angle and it's negative. And it's the same with cos and tan as well. Yeah, that you can get angles that give you positive answers and you get angles that give you negative answers. And there are actually angles which give you sort of similar answers. So for example, if I did the sine of 150 degrees, so if I did sine 150, I get a half. And also if I do sine 30, I get a half. Okay, so there seems to be a link there. And if I do sine of 210 degrees, I get negative a half. So they're all a half, some are positive, some are negative. Are there links with cos and tan as well? Yes, there are. And is there some way that we can summarize all of this information? And yes, there is, in something called a cast diagram. So you'll see this thing that looks like a coordinate grid with loads of lines all over the place. Let me try and make it nice and straightforward for you. So what is a cast diagram? Well, let's draw a grid like this, and let's pretend like we've got angles. So we're going to call this 0 degrees here, 90, 180, 270, and then I can go back around here, get to 360. So basically I'm just numbering this grid with numbers for angles, and I can keep going around this way and get an angle, or I could actually go around backwards and work out an angle. So it's possible to have negative angles as well. Yeah, so I could have a negative angle around there. So I could actually think of this 270 as negative 90, and this 180 I could also think of it as negative 180, and so on. So we can go anywhere we like around this what we call cast diagram. And if I go around in a anti-clockwise direction, it means the angle is positive. If I go around in a clockwise direction, it means that the angle is negative, starting from 0. So 0 is over this side here. Yeah, and we're going to use it to represent lots of different angles. Now, why is it called a cast diagram? C-A-S-T. C stands for cos, A stands for all, S stands for sine, T stands for tan. Now, why have we written those down? Let's have a look at a graph of sine, for example, like this. Yeah, it goes on forever in both directions. Yeah, and let's have a look at 90 here, 180, 270, 360. Okay, let's also have a look at a graph of cos. So that will go like this, and we have 90 here, 180 there, 270, 360 at the end, and also a graph of tan. Don't want to leave tan out. A graph of tan. Sorry, these are not the best graphs in the world. Like this, and we have 90 here, 180 here, 270, 360. And what I'm really interested in is whether the graph is positive or negative. Is the graph above the axis or below the axis? Well, if I look at the graph of sine between 0 to 90, it's positive. So is cos, so is tan. So the A in our cast diagram stands for all. All of the graphs of sine, cos and tan are positive between 0 to 90 degrees. Yes, if I do the sine of any angle, the cos of any angle, or the tan of any angle between 0 to 90, I'm going to get a positive result. Right, let's move along and let's look at the graphs between 90 and 180. So 90 and 180 there, 90 and 180 there, and for tan, 90 and 180. Now, can you see the only graph which is positive between 90 and 180 is sine. So that's why in this cast diagram, between 90 and 180, we have the word sine. This is telling us that this graph is positive. If I work out the sine, cos or tan of any value between 90 and 180, I'm going to get a positive answer. And then we can go around to the next part of the graph. So between 180 and 270, that's negative, that's negative. This is positive. Can you see tan is the only graph that's positive? Yeah, so I suppose I could color code this, couldn't I? Yeah, and we're all positive here. And then if I go on to the last bit, let's use a different color. Let's go for yellow. So yellow, sine is negative, cos is positive, it's above the axis, tan is negative. So that's why we have cos there. So each one of those words tells us which graph is positive, whether it's all of them, sine, tan, or cos. So the other thing about this cast diagram, it links all these equivalent values together. So let's start with sine over here. What's all of this telling us? Okay, so what was sine 30 again? Sine 30 was 30 degrees. Sine 30 was a half. Okay, now let's have a look at this part of the cast diagram here. Theta, I'm going to call theta 30 degrees. Now what this cast diagram is telling me is, if I look at this first part here, it's saying if I do the sine of 180 minus my angle that's between 0 to 90, so that's 30, that will be equal to the sine of the angle 30. Okay, so sine 150 is equal to sine 30, and it is. They're both equal to a half. Okay, let's have a look at the next line down. What's that telling us? So this is telling us that if I do the sine of 180 plus my angle between 180 and 0 and 90, so 30, that is equal to the negative sine of this angle between 0 to 90, this acute angle. So basically it's saying that the sine of 210 is equal to the negative sine of 30, and it is. Sine of 30 is a half, and sine 120 is equal to negative a half. This is what this cast diagram is telling us. All of these different equivalent values, and whether they're positive or whether they're negative. Now, when we go through the examples, we don't really need to memorize all this stuff that's here, all these things here. There's a much easier way to actually work out these values, and I'll show you when we do the examples. So for this question, we're going to use the graphs of sine, cos and tan to help us. So here's sine going up to 1, down to negative 1, 90, 180, 270, 360. They do carry on. If we need them, we'll carry them on. So that's sine, cos, similar thing. So it's going to look like this: 1, -1, 90, 180, 270, 360, and 1 for tan, like this, and again 90, 180, 270, not to scale, 360. So there's our tan if we need it. Right, so part A, sine 90. So all I do, go across to 90, read off, and I get a value of 1. B, sine 180, go to 180, read off, that's a value of 0. C, sine 270, 270 is here, read that off, -1. D, cos 180, so that's here, read it off, -1. E, -90, so all we do is extend the graph back to here. This would be -90, and as we can see, -90 is going to give us 0. And in fact, -90, this is where the cast diagram is maybe useful. We've got 0, 90, 270, 270 here, sorry, that's 180. -90 is the same as this, 270. So we could have actually have read off from 270 and got the same answer. So this is where the cast diagram begins to become useful. So we could actually have said in E that cos of -90 is equal to the cos of 270. And the last one, cos 450. Again, this is where it's going to be useful, the cast diagram rather than the graph. So let's go around. So 90, 180, 270, 360, 450. Right, 450 is there. That's the same as 90. So in F, I could write down that cos 450 is the same as cos 90. By using my cast diagram, it's in the same place, it's an equivalent angle, and cos 90 is 0, so cos 450 is 0. And to draw a cast diagram here, in case we need it, to help us see if there are any equivalent angles that we need to be aware of. So CAST. So part A, tan 45, well that's just 1. Don't really need the cast diagram for that. B, tan 135, okay, let's draw that on. So tan 135 is going to be here, halfway between, and what I'm going to do, I'm going to do this. So this angle is 135, which means this angle is 45. I'm trying to find this angle for tan. I know that this one is 1. So when I worked out that one was 1 from the previous part. Now, is tan 135 1 as well? Well, it is in a way, but because of where it is in the cast diagram, it's negative. It's in the bit of the cast diagram where only sine is positive. So it has the same value or size as 45 degrees, but a different size. So we're beginning to use the cast diagram, draw this cross on, we put the angles in, and we can use that to work out if they've got the same value and whether they've got the same size. So this is actually going to be -1. C. We're on to tan 225. Now tan 225 on my cast diagram is going to be here. This is also on this same cross where we've got a gap of 45 degrees. I could actually put this on as well. Okay, so let's get rid of this and we'll highlight the angle of 225 degrees. Okay, so that angle is 225 degrees. I know that this angle gives me a value of 1. Now, because this is all symmetrical, that the one at 225 also gives me a value of 1. And because it's in the part of the diagram where there's a T, it's telling me that the answer is positive 1, not negative 1. So the answer is going to be 1 again. Okay, D, negative 45 degrees. So let's clear this. And negative 45 is here. That's negative 45. Notice it's on this cross again. Let's just get rid of that 135. We don't need that anymore. Yeah, it's on that same cross, which is 45 degree gap. Now, I know that 45 degrees, the one I did originally, its value was 1. Now, the value of the one that I've highlighted in orange is also 1 because of this size is the same, but it's in the part of the cast diagram where there's a C, not a T. So it's not 1, it's negative 1. If it lands in the part of the cast diagram where that letter isn't, it's going to be negative. So D is negative 1. In black, negative 1. Then E, tan 180. Well, I don't need the cast diagram from this, but I know that tan 180 is 0. And tan 90, that's where there's an asymptote there, that gap. So we say that it's undefined. Okay, because there's an asymptote there. Okay, find the signs of sine theta, cos theta, tan theta in the second quadrant. Right, let's draw it. C-A-S-T. So how do we label these quadrants? Well, this one's the first quadrant, the second, the third, and the fourth. In the second quadrant, I can see that there is an S there, which means that sine is positive, cos and tan are negative. So sine theta is positive, cos theta is negative, and tan theta is negative. If this question said find the signs of sine, cos or tan in the third quadrant, then tan would be positive and the other two would be negative. Right, so now we're going to use a cast diagram, definitely on this one. So part A, we're going to draw the angle negative 100 degrees. So that means we go back 100 degrees, so this is like negative 90. This would be the same as negative 180. So negative 100 is here, round about there. And the angle we're always interested in is the angle between the angle that we've drawn and the x-axis. So this is 80. Now we're going to find all the other angles that have the same value. They may be positive, may be negative, but they have the same value. So to do that, we draw this cross and we put all of these 80s in here. So all of the angles, it's all symmetrical here. Now, the angle that we drew was negative 100, which is here. Let me put the CAST on the cast diagram, CAST. The angle that I drew landed in the part of the cast diagram where only tan is positive. Yeah, so only tan is positive. In this part of the cast diagram, sine is negative, so the sine of negative 100 is going to be a negative number. Also, it has the same value as sine 80, but in this part of the cast diagram, sine 80 is positive. Sine 80 here would be positive, but sine 80 and sine negative 110 have the same value because they're on this same line. So sine negative 100 is equal to sine 80, but a negative of that. Right, part B. So 0, 90, 180, 270. So this time it's cos. Now cos 330, we go all the way around 330 degrees. This angle here would be 30 degrees. That's the one we're interested in. Now we extend these lines, draw a cross. These are all going to be 30. These are all the angles that have the same value of cos 30, but some will be positive, some will be negative. That's what we're going to work out. So CAST. The angle that we drew was this one, and it's in the part of the cast diagram where cos is positive. We want it as an angle in the 0 to 90 part, and it's also positive. So not only do they have the same value, they have the same sign. So cos 330 has the same value and the same sign as cos 30. Last one, part C, which is tan. So we draw a cast diagram and we do 500 degrees. Now 500 degrees, where's that going to be? Well, if I go around the full term, this is going to be 450 and this would be 540. So 500 degrees is like there, which means this is 40 degrees, which means that all of these are 40 degrees in this cross, this symmetrical cross. Now I drew my angle here in the part of the cast diagram where only cos is positive. Put that in, CAST. Tan would be negative there. It would have the opposite sign to tan 40. Because of where it is in the cast diagram, it has the opposite sign to tan 40. So tan 500 has the same value but the opposite sign to tan 40. Okay, you should now be able to do exercise 10A on pages 207 to 208. So remember our cast diagram, which we can go around in a positive direction, get positive angles. We can keep going around as much as we like around here to get our negative angles, and our angles are 0, 90, 180, 270, but we can keep going. 360, you could even call that negative 360. This would be the same as negative 90, and so on. So we put our angle in, we draw this cross, and we use it to work out angles which have the same value but may have a different sign, and we can tell whether they've got the same sign or not depending on the letter that's here, they're all positive here. Whereas in the other parts, only sine, cos or tan is positive.